Hello, everyone. In this video, we will answer an exam about derivatives. Part 1. Write the notation of the required derivative. Number 1. Charge and current. The electric current I at time t is the rate at which electric charge Q flows through the cross-sectional area of a conductor per unit time. Write I as a derivative. Answer. The instantaneous current I of t is the derivative of the electric charge Q with respect to time t. Therefore, I of t equals the limit of delta Q over delta t, as delta t approaches 0, which is known as the derivative of Q with respect to t. In other notations, I of t equals Q prime of t equals the derivative of Q of t with respect to t. Number 2. Velocity and acceleration. The position x of t of a body in a straight line motion refers to its distance from the origin O at time t. A. The instantaneous rate of change of the position x of refers to the instantaneous velocity v of t, in other words, the velocity at time t. Write v as a derivative. Answer. The instantaneous velocity v of t is the derivative of the position x with respect to time t. Therefore, v of t equals the limit of delta x over delta t, as delta t approaches 0, which is known as the derivative of x with respect to t. In other notations, v of t equals x prime of t equals the derivative of x of t with respect to t. B. The instantaneous rate of change of the velocity v of t refers to the instantaneous acceleration of t, in other words, the acceleration at time t. Write it as a derivative. Answer. The instantaneous acceleration of t is the derivative of the velocity v with respect to time t. Therefore, a of t equals the limit of delta v over delta t, as delta t approaches 0, which is known as the derivative of v with respect to t. Therefore, a of t equals the limit of delta v over delta t, as delta t approaches 0, which is known as the derivative of v with respect to t. Number 3. Work and power. The work W done on an object is the product of the force F and the displacement S, in other words, change in position, of the object. The instantaneous rate at which work W of t is done refers to the instantaneous power P of t, in other words, the power at time t. Write P as a derivative. Answer. The instantaneous power P of t is the derivative of the work W with respect to time t. Therefore, P of t equals the limit of delta W over delta t, as delta t approaches 0, which is known as the derivative of W with respect to t. In other notations, P of t equals w prime of t equals the derivative of w of t with respect to t. Part 2. Find the required quantity using derivatives. Number 1. The slope in the equation of the tangent line to the curve of f of x equals the square root of x at x equals 4. Solution. A. F prime of 4. Use the limit definition of the derivative of a function at a number. Substitute f of c plus delta x and f of c. The answer is an indeterminate form of type 0 over 0 which does not provide an information about the limit. Next, rewrite the limit expression by rationalizing the numerator. Multiply the numerator and the denominator by the conjugate of the numerator. Simplify. And then, evaluate the limit. Hence, f prime of 4 is equal to 1 over 4. The slope m of f of x equals the square root of x at x equals 4 is 1 over 4. B. The slope m of the tangent line to the curve f of x equals the square root of x at x equals 4 is also 1 over 4. Therefore, the equation of the tangent line is y equals 1/4 of quantity x minus 4 plus 2. The following figure illustrates the graph of f as well as the tangent line at x equals 4. The slope of the tangent line is 1/4. Number 2. The direction of motion r prime of t at any point, x, y, if the position vector is given by Solution. Find the derivative of each component of the position vector. X prime of t. Use the limit definition of the derivative of a function. Substitute x of t plus delta t and x of t. Combine like terms and simplify. Evaluate the limit. Thus, the derivative of x with respect to t is 2 y prime of t. Use the limit definition of the derivative of a function. Substitute y of t plus delta t and y of t. Expand the square of a binomial. Combine like terms. Simplify and evaluate the limit. Thus, the derivative of y with respect to t is 2t. Thus, the direction of motion r' of is the derivative of each component of the vector r. Therefore, r' of t is equal to 2i plus 2tj. Number 3. The curvature of f of x equals x squared at x equals 0 and x equals 3 provided f' of x equals 2x and f double prime of x equals 2. Solution. The curvature is given by substitute the first derivative and second derivatives of f. At x equals 0, the curvature is equal to 2, which means the radius of curvature is 1/2. The figure on the right shows the radius of curvature of f at x equals 0 is equal to 1/2. At x equals 3, the curvature is equal to 2 over 37 times the square root of 37. Which means the radius of curvature is 37 times the square root of 37 all over 2. The figure on the right shows the radius of curvature of f at x equals 3 is equal to 37 square root of 37 over 2. Number 4. The location of the maximum and minimum of points of the function f of x equals x cubed minus 4x. Located in the closed interval, -2, 2. Solution. First, find the derivative of f with respect to x. Use the limit definition of the derivative of a function. Substitute f of x plus delta x and f of x. Expand the cube of a binomial and combine like terms. Simplify. And then, evaluate the limit. Accordingly, the derivative of f with respect to x is 3x squared minus 4. Afterwards, solve the roots of the equation f prime of x equals 0. Equate f prime of x to 0. Solve for the values of x. Therefore, the maximum and minimum of f are located at x equals positive or negative 2 square root of 3 all over 3. The following figure illustrates the maximum and minimum of the given function. F is the red curve, while its derivative is the blue curve. The locations of the minimum and maximum of f are located at the zeros of its derivative. Finally, calculate the value of the maximum and minimum. Substitute x equals 2 square root of 3 all over 3. Next, substitute x equals negative 2 square root of 3 all over 3. The maximum and minimum values of f in the closed interval, negative 2, 2, are 16 square root of 3 all over 9 and negative 16 square root of 3 all over 9, respectively. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.